Hi everyone, welcome to the 56th session of Python for Machine Learning. In this session, we will learn about the polynomial linear regression using the scikit-learn library. We will plot, we will get the salary based on the experience. We already have our data set with us. So we'll execute this, and if we see, this contains the year of experience and with the salary along with the years of experience. We will normally plot like what we have done in the session from 30 to 35, the detailed discussion we had about linear regression, and in the session number 52 I have shown you how to use the polynomial linear regression without using scikit-learn. Till sampling we'll execute it, and from there we'll start our coding. Okay, so till sampling is done, and now what we need to do is we need to create the regression model as usual, and then after that we need to create. So for that we'll give from sklearn dot linear model import linear regression, and then we'll create the object of linear regression. Now what we need to create the polynomial features, and then for that what we'll give from sklearn dot preprocessing import. What will import the polynomial features, and then we'll create the object of this polynomial features. Suppose we give a degree of 2, that we will see once, and then we'll give x underscore poly, which is equals to polyreg dot fit underscore transform, and then we need to fit what features. Like we have already extracted the features and labels, and I have not shown you how because I have already explained in the previous session, so I'm just directly starting. Okay, and then we need to, once this is done, we need to show the we need to test the model. For that, y underscore pred is equals to regressor, but before this we'll execute these 3 lines. Okay, we'll execute from here. Fine. Regressor dot what we'll get, predict, because we are going to predict the values, salaries. Okay, and we need to regressor dot predict, and then we give polyreg dot fit underscore transform, and we need to pass here x underscore test. Maybe we're missing something here. We need to give regressor dot fit, but we have to do the fitting x underscore poly comma labels. Okay, now if you go to your variable explorer, if you open your xpoly, not xpoly, yeah, ypred. Okay, and this is your y test. So you can see the model is not 100% correct, but it's coming nearby values. Like this is 40,000, and here it is 37,731. For this 1,23,122, almost there. So it is doing like good predictions, we can say. Now if you want to calculate the accuracy, polynomial regression accuracy is how much? How to calculate the accuracy? That will give regressor dot score that we have used in the previous session, and then trigger poly dot polyreg dot fit underscore transform, and then we need to pass x underscore test, and then that will be followed by comma y underscore test. So if we execute this, so our accuracy is 97%. But if we again want to do this, change the equation. No, but before this, for the second degree equation, what is my like? We give regressor dot cu coefficient. So what is the coefficient here? 9529, right? See this 9529 and this is 16.39. So it is matching. And if you give regressor dot intercept, this is 26215. It is being round off, so it's coming perfectly. Now if we want to give a degree, check it with a degree of 3. So what will be the my accuracy? Accuracy is improving actually. And if I want to check the coefficient, so what is the coefficient there? Coefficient and also the intercept we'll check. Okay, so these are the coefficient and intercept, and we will verify with this equation. This equation we have got by checking in the Excel. I have already shown in the session number 52. Okay, so here you can see the intercept part is 38863, then -78. If you go from here, then 2099, which is coming perfectly, and then -122. So this is working quite. Now if you want to, like, this is mechanical. If you want to execute, suppose you want to check for the 6 degree at one go, what will be my uh, the, the the accuracy score? So we can use this for loop. But if the data is huge, then it's no point in taking this this approach. And then print uh, intercept. Then we'll print the accuracy, which is so now we need to simply execute this. And so okay, so for first degree the accuracy is 97.9768. For second degree it's decreasing 9766. For third degree it's increasing. For fourth degree it's even increasing a bit more. For fifth degree it is like even decreasing further. And also if you want to see the coefficient and the intercept, so you can see this coefficient 944, it is being round off, and then 25 intercepted to 5972. For the second degree the coefficient intercept is 26 this and this value, and whereas the coefficient is you have to come from back, like 16.39 x square plus 9529 x to the power of 1. And then for third degree the value is matching 388 for third degree, 38863, and here 38863. And similarly will be a value if you are coming from this and this -122 2099 718, -122 2098 -78. This is how we can get the value, and we can also cross verify, which is one of the very important thing, like whether the work which you are doing is correct or not. This is the way how we can verify your linear model for polynomial linear regression. So thanks a lot for watching the session. If you feel this video is helpful, please subscribe to this channel, and I'll see you in the next video. Thank you.